This is GATE 2016 set to electrical question number 45. A full bridge converter supplying an RLE load is shown in the figure. The firing angle of the bridge converter is 120 degree. The supply voltage Vm equal to 200 pi sine 100 pi t volts, R equal to 20 ohm, E equal to 800 volt. The inductor is large enough to make the output current IL a smooth DC current. Switches are lossless. The real power fed back to the source in kilowatts is being asked. For NPTEL reference, you can refer to lecture number 7, Single Phase Control Rectifiers, part 2 of the NPTEL course Power Electronics by Professor G. Bhuvaneshwari, Department of Electrical Engineering, IIT Delhi. For useful data, you need to know that if the supply voltage is like this and pulses are given like this, T1, T2 is fired at alpha, T3, T4 are fired at pi minus alpha, then the output voltage will look like this. When T1, T2 are kept on, the output voltage starts following plus V in and goes like this, but here still T1, T2 are on, so it follows the plus V in. Now T3, T4 becomes on and it starts following V in. This will be actually like this. This will be 2 pi and this will continue like this. After 2 pi, the V in becomes like this. However, T3, T4 is still on, so it follows minus V in, so it is like this. Now, when we find the average of this V0, it comes out like V0 equal to 2 Vm by pi cos alpha. Now it is obvious that if alpha is greater than 90 degree, V0 is negative. Now, if a battery is like this, the polarity is like this, and the current also comes out from the positive terminal, then it is said that the power is delivered by the battery and the battery discharges. Now, similarly, consider this case, this is the RLE load, and if the RLE load is delivering power to the source, then the current should come out like this, that is, the battery should discharge. So, following this loop, if you write the KVL, you will see that from here to here we need to go. So V0, what is it? It is equal to plus IR drop, because from plus to minus we see a drop is coming, so V0 is drop, so IR is drop, which is also positive, and this E is gain, so minus E will come. So V0 equal to minus E plus IR. Coming to the solution, this V0 2 Vm by pi cos alpha will be equal to IR minus E. Now E is given to be 800, so I into R value is given to be 20 and E value is 800. 2 times Vm, the maximum amplitude is 200 pi, so 200 pi divided by pi into cos 120 degrees, because it is mentioned that firing angle is 120 degree. Cos 120 degree is minus half, so minus half, and then pi gets cancelled, so minus 200 equal to I into 20 minus 800, so 600 equal to I into 20, which implies I equal to 30 ampere. Question asks to find the real power fed back to the source. So now we find the value of current. So the power delivered during this condition is 2 Vm by pi cos alpha, which is the average V0 average. This will be constant multiplied by 30 during this power delivered condition. So this time the power delivered is P delivered is equal to this, which is equal to 6 kilowatts, and with a minus sign because this V is negative, so minus 6 kilowatts. 2 Vm by pi cos alpha is calculated to be minus 200. So if I write it, it is minus 200 into 30 watts, which is minus 6 kilowatts. So this is the answer. So now since it is asked real power fed back to the source, since already it is written fed back, so you don't need to write minus sign, so you write 6, because in kilowatt it is asked, so only 6 you write. This is the answer. Thank you.